Today we're going to talk about the law of cosines. In this particular video, we will look at the law itself, the formulas. We will generalize the big idea behind it, and look at a couple of examples. In subsequent videos, we'll look at using area formulas and Heron's formula as well. So the law of cosines, now we are going to be, all this notation here is going to be using a conventionally labeled triangle where the side lengths A, B, C have angle measurements of alpha, beta, and gamma across from those sides. So depending on which side and angle you have and looking for, it would be A squared equals B squared plus C squared minus 2bc cosine alpha. If we have different sides and angles, it might be B squared, equals A squared plus C squared minus 2ac cosine beta, or C squared equals A squared plus B squared minus 2ab cosine gamma. Now, you can definitely see a pattern in here where the cosine angle that we're looking for is the angle that is across from the side that is isolated. That I've got an alpha here, A here, beta and B, as well as gamma and C. The other thing that is helpful to watch and look for is that these values, because of the orange, it's not going to be a very different color. Maybe I can choose a different highlighter here. That does not highlight very well. Maybe I can do an underline. That B and C are involved there. A and C are involved in 2AC. A and B are involved there. So there's some patterning to it to help you remember. The other thing that a lot of people would tell you, and it's definitely something you can definitely use, is that the beginning piece definitely has some similarities to the Pythagorean theorem with something tacked on to the end. The other thing that you should notice is, especially at the end there, the 2bc cosine alpha, 2ac cosine beta, and 2ab cosine gamma. In all three cases, you are dealing with two sides and the included angle. So you can generalize a little bit that you would over here have some side length squared. And then over here, you would have cosine of the included angle. And that helps a little bit. And that included angle is the angle, like I said before, directly across from that side squared. And so on and so forth. We can't use hypotenuse and leg here because these are going to be oblique triangles that we're looking for. In general, once again, like most any particular formulas, if you have all but one, you can solve for the missing value. Here we have three sides, A, B, C, and one angle, either alpha, beta, or gamma. If I have 3 out of the 4 values, I can figure out that fourth value. And this allows us to find values that we couldn't do in traditional geometry classes. And we'll show that with a couple of examples right now. So our first case is solve triangle ABC given A being 5, C being 8, and beta being 77 degrees. If we make a quick diagram of this for some triangle, if I mark this as 77 degrees, so that makes, if that's beta, that makes this B. Maybe I'll mark this as A and this as C. that means side A it would be marked here as 5, and side C would be marked here as 8. So we can see here, this example is a side angle side scenario. We've been given two sides and the included angle. For this particular case, according to the formula, since I have two sides and included angle, I'm missing a side. So I'm going to use the version of the formula that will help me find side B. So I'm going to use B squared equals A squared plus C squared minus 2AC cosine beta. So that B squared is going to equal 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of 77 degrees. 25 plus 64 minus 80 cosine 77 degrees. And let's see, 89 minus 80 cosine 77 degrees. At this point, I'm kind of stuck. That's a B squared. I'm going to go B equals the square root of 89 minus 80 cosine 77 degrees. Yes, I know that when you take the square root of both sides, you should have plus or minus, but because we're dealing with an angle measurement, I'm dealing with a side length here, the negative would not make any sense. So I would take this expression, put it into my calculator in one fell swoop to try to retain a high degree of accuracy and get the side length B. So why don't you take a moment, pause the video, do that, and come back and see what we get. If you're back and you've done that, you should get that B is approximately 8.4 for a side length there. So that's our side length B. I'll write that up on our diagram, 8.4. We'll go full screen here. So now we have all three side lengths, and we have one angle. Now we need to find the other two angles. Now, because I have all three sides, I could do this a couple of ways. I could either use the law of sines to go ahead and find the missing angles, which would be perfectly fine. But since we're practicing the law of cosines here, I thought maybe we'd use the law of cosines to show you how we could use the law of cosines to do that. I'm going to take all this. I'm just going to put it all together. I'm just going to move it out of the way and put it up here. If you need to see that again, you can rewind the video. But let's see how we would find an angle here. And it doesn't matter which angle we find. Let's say we want to find angle alpha next. So I want to look for angle alpha. That means I'm going to use the version of cosine that says A squared equals B squared plus C squared minus 2BC cosine alpha. That alpha is what I want to solve for. So I chose the version that has alpha in it. I plug in the appropriate values. 5 squared equals 8.4 squared plus 8 squared minus 2 times 8.4 times 8 cosine alpha. And I can see here that I am going to need to use the inverse cosine function eventually to solve for alpha. A little bit of work here. I can really say this is going to be 5 squared minus 8.4 squared minus 8 squared divided by 2 times 8.4 times 8 is going to equal cosine alpha. And that is just a whole bunch of algebraic stuff, subtracting from both sides, dividing both sides, to isolate the cosine alpha in our equation. That's going to get a little small if I keep extending there. So now I could use my inverse cosine function. So the inverse cosine of 5 squared minus 8.4 squared minus 8 squared all over, oh, I need a negative in front of there, negative 2 times 8.4 times 8 is going to give me the alpha that I'm looking for. And this expression, if you want to simplify that ahead of time and figure out what that is, and then use the inverse cosine function, go right ahead. Feel free to do that. If you want to just put that into your calculator in one fell swoop, that's fine too. We're going to use our inverse cosine function here, making sure it's in degree mode because that's how this triangle is. So let's take a second and do that. And when we do that, we get approximately 35 degrees. And that should make some sense to us because A was our shortest side. So alpha should be the shortest angle. So now I've got my alpha being 35 degrees. It's a matter of finding angle gamma, and really angle gamma in this particular case, all we're going to use is the triangle sum being 180 degrees for the angles. And we're just going to do that. Let me shrink this, slide that out of the way. And so for angle gamma, gamma is going to be 180 minus 77 minus 35. So that's not great notation. Let's rewrite that. Gamma is 180 minus 77 minus 35, which is 180 minus 112 minus 112. And that is going to give us 68 degrees, if I'm not mistaken. So now we've solved this triangle completely. We use the cosine function twice, once to find a missing side length, once to find a missing angle length. And that's really the big idea of what you can do with the cosine function. The law of cosine. Sorry, you can use the law of cosines to find missing sides if you have two sides and an angle. And you can use the cosine function of a missing angle if you have all three sides. I'll make some subsequent videos with a few more examples about how this works with just some more cases.